solution for this. Some of them did say between 0 and 4. Some said between 0 and 2 pi. I think most of them were between 0 and 2 pi, right? Okay, so now, any problems with this? Tell me where the concerns are. We solved? How did we find it in the bottom two quadrants? Okay, when you take a square root, it's all four quadrants. So now I'm dealing with all four. Now, see how this one comes straight through? Alex, watch. See this one comes straight through? If I name this one and add 180 pi, I'll get this one. So I name this one, 45 goes into 184 times, and I add n pi. Now, when I name this guy, won't I come straight through 180 and get that terminating side? If I name this one, so this would be 4 pi over 4, this would be 1 less 3 pi plus n pi. So now I got this one, and that one, that one. Rather than do all 4 plus 2n pi, you can take a shortcut, because you can come straight through the origin, straight through the pole. So you have 4 solutions, and if you only had to give me between 0 and 2 pi, you only had to do this. This is any, all solutions. This is between 0 and 2 pi. You had 4 angles that made this between 0 and 4 pi. Now, if you come down here and you don't like cosecant, it's the reciprocal of sine. If you take its reciprocal, then take this reciprocal. 1 over radical 2, you kind of recognize that as your 45, 45. If it's easier to recognize, you're kind of seeing the same numbers all the way through, aren't we? We're not seeing really different numbers. We're seeing radical 3, radical 2, 1, and 2. Because those are the parts of your two special triangles. If I gave you something else, you wouldn't be able to find your angle.
What do you know what to do with triangle?
Based on this right here. Now, in this case, we had a plus or minus. Plus or minus is everywhere. And normally, if it said, where is the cosecant of x negative, then I would say, where is my sine negative? I do it by this. I say sine is y. So y is negative down here. You have a triangle here and here. If y is positive, you're up top. If x is positive, you're here in these two. If x is negative, you're here. That's the same as your all students take calculus, chemistry, whatever you use. I don't use that, but a lot of kids do. So if I say all students take chemistry, sine is positive here and here, so it's got to be negative here and here. But I like to use the x and the y. I think it just makes more sense. And plus, I'd like you to see the fact that this is imposed on your grid. It is on your graph. So there's a lot of similarities here. Okay, this guy. Tangent. We solve for tangent, we take the square root. Again, you get a plus and minus. You got all 4 quadrants. And tangent is y over x. So put an over 1. When both your sides are 1 and 1, you have a 45, 45, right? The angles have to be the same if the sides are the same. Not the hypotenuse, the legs, the sides. So now I know again. So again, I have the same situation that I had above. If I label this guy, I can shoot across here, give it a plus n pi. If I label this guy, I can shoot across there and give it an n pi. That's all solutions, and then from 0 to 2 pi, there's my 4 solutions. At any point, plug them back into your equation to see if they work. Yeah? Sometimes with the plus or minus, you kind of have to plug them back in. Because sometimes when we square something, it may not work. It may not work out. Okay, again, you have cosines on both sides. If this is confusing, start like this. Yeah, that looks kind of weird to me. I cannot divide by x. You can never divide by your variables. So you get that to one side, and then you factor. Get this to one side and factor. This is nice, too, because your cosine squared. your cosine here, your two separate pieces. You could either add 1 to both sides and do it this way. This is fine. I just did it with your perfect squares this time. Square root of 1 is 1. So now, if it's negative or positive 1 for the x value, you have two pieces, here and here. And then this guy was when x was 0. You have two pieces, here and here. So you actually have all 4 quadrants in your answer. Work a section at a time and make it make sense. I did those as perfect squares just because we were factoring, so I factored. But could you do it the other way? Absolutely. I know these always look strange, and everybody panics because, like, what do you want me to do with that? But remember, you can't cancel out one of your variables. You have to factor it out and use your factors. Good? How many of you are picking up the angles part? Like where to find the angles? Did it make more sense after last night? Only got one hand on that. 1, 2, good. A little bit more.
I'm not here.
The middle angles, which for this one or for that one? These guys didn't actually have an angle with a triangle. These, because, did you get a plus or minus 1? A plus or minus 1 says x has to be 1 or negative 1. So when x is 1, here's my point. That's a quadrant angle. 1, 0, negative 1, 0. When cosines and sines are 1s and 0, it's on a quadrant. Because what it's saying is this, x over r. If my x goes out 1 unit and my r is 1, I'm right there. If my x goes out negative 1 units, my r is 1, I'm right there. When your r and your x are the same, you're a quadrant. Or your r and your y are the same, you're a quadrant. It can't make a triangle. So it uses the axes. Does that kind of help? So you've got the 0 and the pi. So there's your 0, there's your pi. Now for this guy, it was when x was 0. So you have two situations, when y is negative 1 and when y is 1. X is still 0. So therefore, it made that one and that one. Yeah, anytime you have zeros and ones, put this over 1. Your x didn't move. Watch. If your x doesn't move, it stays there, but your radius was 1. It could go that way or that way. Your quadrant angles are always the tougher ones, because everybody's trying to draw a triangle. But if your x is the same as your r, it's got to be on a quadrant. If your x is 0, that means it didn't move off that point on the x, but it could move on the y, right? If your radius is 1. Okay? All right, this one was a little bit of a big one. All right, you had to do a substitution. You had a sine and a cosine in one. You did these last year, believe it or not. You just didn't find all solutions. You had to take this. You can't break down cosine any more than that. But you can break down your sine squared. We did one of these yesterday. And sine squared plus cosine squared equals 1. That is the one identity you have to remember. That's your Pythagorean identity. Remember when we did the unit circle and the radius was 1? This was the x, this was the y. This is Pythagorean's identity. And you just substituted in your cosine, then you substituted in your sine. That's Pythagorean's identity. That's the one that you have to remember. And we tell you all through Algebra 2. If you don't remember that one, when you come to that one statement, you'll never get further than that. So we replace that. Now, here's a big problem. Here's my equal sign. 2 minus 2 is 0. Not subtract 2, subtract 2. You're on the same side of the equal sign. So that cancels out. This is a negative in front of here. If I don't, and I never like to factor this with a negative. You could on this one because you're only factoring out something, but try to keep this positive. It's a equation, so divide or multiply by -1. I was going to say it's a fraction, but it's not. We don't need a fraction. Now, when you come here, notice they both have a cosine. You could have taken out a negative cosine, you would have been fine. Keep it positive, it makes it easier. I always find the negative, once it comes out, sometimes the sign in the middle, then you get it wrong. So keep that guy positive. Now, here's your pieces. So your cosine is equal to x, which we just saw in the other one, right? For 90 and 270. And then your cosine is equal to 1/2. So we found this guy. Here's your cosine is equal to x. Your x is equal to 0. Your cosine is 0. And your 1/2 says your x value is positive. Oops, I wrote over mine. This is a -1/2. Where's your x value negative? Over here. So you've got two triangles in quadrants 2 and 3. Find your reference angle. X over r. So this guy is radical 3. So your reference angle is 60. How many times does 60 go into 180? 3. So therefore, 3 pi over 3, and we don't really care about 6 pi over 3. So you're 1 less, 3 pi over 3, and 1 more, 4 pi over 3. You only have to go between 0 and 2 pi. So here's your solution. That substitution, it just makes for, like, silly errors. The negative sign, the 2 minus 2 on the same side of the equal sign. I always find that to be, even my pre-calc honors kids, subtracted 2, subtracted 2. Draw a line down your equal sign, and make sure you collect all your terms. Good? A substitution. You can't do 2 variables in one equation. So we've got to get rid of one of those. Cosine, that's the lowest it goes. So we can't get any lower than that. But sine squared, we can replace sine squared in terms of cosine by using this identity, which is the one you have to remember. That's the one that you have to remember. So if we solve it for sine squared, we can now take this out and replace it with how we solved it in terms of cosine. And then everything is cosine. And then the rest is, distribute, collect select terms, factor it. You're back on track. Questions?
No.
Good? All right. Okay. All right, this guy, well, you got secant squared and secant plane. It's like x squared minus x minus, well, move the 2 over, minus 2. So factor it. If you have trouble, just factor this first. 2 factors into 1 and 2. So I get a 2 and a 1, doesn't matter where. What matters is where my negative goes. I want the greater one to be negative. And then fill in your secant words. Now, when we get here, if you don't like looking at secant, take its reciprocal. Its cosine. If you remember your sine and your cosine curves and how we did your reciprocals off of those, here's your cosine. Here's your secant curve. Look at the only time that the 1 touches, or in this case, the -1 touches. Do you see the graph? Does this make it easier? What value is that? There's your pi. If you sketch it, I think it looks easier than a triangle because you're at a quadrant. You're at a quadrant. If you flip this over and you take x over r, that's fine too. Your x has to be negative. There's your -1, 0. I like the sketches because I think it kind of makes more sense. This is the only form that they touch at the 1s and the -1s. This one said secant is 2. Flip it over, use the cosine. X over r, or do r over x over here, if that's easier. So you only had to give me from 0 to 2 pi. Daniel? Oh, you agree? Good? I guess? No, you need to know this. I seriously, is this the end or we?
Oh, we got like 44.
44. Now, this one has secant and cosecant. It has two different variables. Get everything to one side. Factor it. When you factor, you get your cosecant out of there. Now you have two factors with two different variables. You can set them both to 0. And it makes more sense that way. Now, again, this one has my cosecant at 0. Here's my sine curve. Look where my cosecant goes. Am I ever at a 0? No. The zeros, aren't your asymptotes at zeros? If you think about your curve. So this guy has no solution. If you flip it over, and take its reciprocal and go to the sine, that kind of makes more sense. You can't have 1 over 0, right? For a be a sine, which is divided by 0. So this part has no solution. So we look at this part, and you have 2 that satisfy that. And don't forget to visualize these sketches, because personally, I think the sketches make a lot of sense. Good? Yo, Aaron. I thought you said yo, man. I can't either.
I don't get how you got to the second part.
This part?
No, like, yeah, to the factory.
Factoring? Okay. Guys, what if we make this an X? And I make this guy a Y? What should this one be? 2Y. So, this is what you're looking at. Guys, Aaron has a good thing here. I can't divide by Y. I got to get everybody to one side. Now I can factor. I can take out a Y. So essentially what we did here, we took out a cosecant. You cannot divide by your variable. You cannot. Good? Done? How'd we get the angles? This guy, we decided there was no angle. Because you'll never find a cosecant equal to 0 because they're all at the ones and the negative ones. They go the opposite way. It would have had to be here, right where your asymptote is. And if we flip this over, took its reciprocal, sine, if we put this over 1 and we did this, this can never happen, 1 divided by 0. So this had no solution. So then we came here. We said now we have a secant that's equal to 2, 2 over 1. Secant is r over x. So cosine is positive in 1 and 4. R is 2, x is 1, this guy, radical 3. Now, if you don't like to look at secant, take its reciprocal. I think the reciprocals are probably easier to look at. I have an angle whose cosine is 1/2. A positive wherever the x's are positive, which is 1 and 4. And I find that's a 60-degree reference angle. So we say pi over 3, and this would be 6 pi over 3, the 6 pi over 3 here, 3 pi here, 6 pi here. We're 1 less, we're 5 pi over 3. We don't care about this side because there was nothing on it. Okay? From this little reference angle. This is our special triangle opposite the radical 3, and 60 goes into 180 3 times. So your first quadrant angle is pi over 3. Good? Guys, what we're going to do is work a double angle just a little bit differently, or a triple angle, or whatever it is that we need. Now, we're going to solve this. You notice here's the triple angle. We're going to solve this as if it said x, right? So we're going to go through this and solve. So we're going to add 1. We're going to divide by 2. Okay, and this is a triple, but we're going to treat it as an x right now. And we're going to find our solutions from 0 to 2 pi. So let's look at our solutions from 0 to 2 pi. So where is cosine? Treat this as 1 right now. Treat this as an x right now. Where is cosine positive? 1 and 4, because x has to be positive. Think of where x is positive. 1 and 4. So we label x over r. What's our reference angle?
Oh,
60.
60. Thank you.
You're welcome.
Okay, so how many times does 60 go into 180?
3.
So this would be pi over 3. And what would this angle be over here?
0.
5 pi over 3, because this would be 6 pi over 3, wouldn't it? This is 3 pi over 3. This is 6 pi over 3. Now, what we found here is from 0 to 2 pi, we found it for 3x. Okay? Now what we have to do is find this for 3 times the amount of this angles. Now we're going to come back to finding the rest of these in 2 pi in 1 second. So we're going to come over here and we're going to say 3x is equal to pi over 3 plus 2n pi, right? Aren't these all solutions? And 3x is equal to 5 pi over 3 plus 2n pi, where n is any integer. Didn't we do this as before? Right? To come around 2 pi, to come around 2 pi. Right? For all solutions. Now, here's our problem. This says 3. So to get rid of this, I divide by 3. So I'm going to take this, now this is an equation, divide everything by 3. So, guys, come on. This is x is equal to, if I take pi over 3, and I divide it by 3 over 1, I keep, I change, I flip. What does that give me? Pi over 9. So, pi over 9 plus 2n pi over 3. I can't reduce that anymore, so I leave it. So that's my solution in here. But I gotta say n is any integer. But all we did was divide by 3. Divide by 3 here. So what do you think this becomes if I keep changing flip? X equals 5 pi over 9 plus 2n pi over 3. And I also have to say n is any integer. This is my all solutions. So I start out finding my solution between 0 and 2 pi, and then I take out my 3x, and I leave it like that. Questions so far? Aaron?
So, for one of them, you use the top triangle, and then for the other one, you just...
Well, right now we treated it as an angle over here. We treated it as one angle, right? Because isn't that what we always used to do?
Okay.
Like, say this was x, not 3x. Didn't we find where x was, where the cosine was 1/2? Like this? But notice, I didn't say x equal, I said 3x equals. So we leave it like this for a second. We found 2 solutions from 0 to 2 pi. One I use x, but my 3x is in there. So we're gonna, like I said, we're gonna come back and finish this part. But I needed these to go to all solutions. So now we came to all solutions, and we normally say, doesn't this come back around 2 pi, and this guy come back around 2 pi? So 2n pi each time. But then we just have to get rid of your x. Now, Now we're going to go back and find all our solutions between 0 and 2 pi. Now, I need your undivided attention. How many triangles, so to speak, solutions did we find using an x? 2. If we said we had 3 times the amount of angles, how many should we now find? 6. So we found 2 in here times the 3. We should find 6 angles from 0 to 2 pi. Okay, stay with me. Your denominator here is 9. Flip this into ninths. How many ninths is 2 pi? 18 ninths. 18 pi over 9. That's where we remember how to stop, right? We're going to stop at that. Notice down here, pi over 9 plus 2n pi over 3. Do they have the same denominators? No. So let's take 2n pi over 3 and convert it to ninths. So 6, this would go in 3 times this, 6n pi. So every time we go to add an angle, we're going to add 6 pi over 9. We're going to keep adding that angle until we reach our limit. So I'm going to bring it up here. We started with pi over 9. That's 1. Add 6 pi over 9. What do you get? Remember, the denominators are the same. Add 6 pi. What do you get? 7 pi over 9. Add 6 pi over 9. 13 pi over 9. Add another 6. 19. But I'm over the 18. So I stop. Okay? Now I'm going to do the same for this angle. Kind of like we did the other day when we had to convert them to the same denominators. So I'm going to add, again, 6 pi over 9. Add 6 pi over 9 to this guy. 11 pi over 9. Add 6 pi again. 17 pi over 9. Add 6 pi again. You can't because you're over the 18. So didn't you tell me I would find 6 solutions? 2 times 3, 3 times my triple angle there. Right? Do you see it? So I just want, give me your attention for a second. Look what we did. We solved it as if it was x. We went to your quadrants. We found where we located it. And then we said, okay, I found the 2 angles, but don't forget, this is 3x. So then we came down here, and we said, this is equal to 2n plus 2n pi. We divided by 3. And then we found all solutions between 0 and 2 pi. Okay, try those for tomorrow. Try those. Go over this example, guys.